So I'm going to talk about working spatial data in Julia. So the spatial data, I'm in here the data at OpenStreetMap that is divided into several levels. OpenStreetMap is kind of Wikipedia for maps, so we have all this data about the world that is around us. The data is available via XML and PBF, and it's multi-layer structure. There are things like nodes that represent points, ways that represent lines, and relation. And each of these can be tagged. So for an example, this is the campus that we are currently here, and this is an XML representation, like you have, for example, some building, Cambridge, and number 33. Okay, so this is the data, and now this is the set of libraries I'm working on. So these are the libraries working for mapping data. And those libraries include OpenStreetMapX for processing of spatial data. So this library is mainly oriented onto the road system. So if I have a road system, a system of roads, it allows to extract roads as graphs. And this is our particular graphs.jl graph. It supports routing, road classes, vehicle speeds, etc. So some basic information about routing. There is also a kind of overlap with the package geodesy.jl because it's also supporting some algebra, some spatial algebra processing the coordinates. Now the next package, a corresponding package, is for plotting. So we have a map, you can plot it using plots.jl or pyplot. And now I'm working on another package which is work in progress and should be registered soon. This is a package OSMToolset, and this has tools for extractions of points of interest and for slicing of maps. So this is the ecosystem that is being developed. So this is how you use the packages in OpenStreetMapX, OpenStreetMapX plot a fire. So this is the Boston area around us. And for example, here I'm calculating a route from the point A to the point B, and this is how you can plot it, and you are getting such a plot as you can see at the background. So this is part of the package. Now, the package I'm now working on is OSMToolset for extraction point of interest. And basically, it works like this, that you define what type of points of interest you want to extract. So for example, here, some sporting attractions, but this is just a small part of the table. So this could be restaurants, pubs, businesses, and so on. Everything, all the world around us, at least in the United States or the Western and Europe, it's cataloged on OpenStreetMap data. And then we have like find point. So I take some small part of central Boston, and I'm finding all the places of interest from this setup. So this is what I'm finding. So I'm finding the information about the places. Now this is a plot. Here I'm using a leaflet via PyCall. So this is the data that has been extracted in the previous step. And here you seeing all the locations around our conference venue. Additionally, they have been divided into 8 classes with 8 colors, like parking spaces are blue, restaurants are red, and so on. So this is the spatial information. Now, the next thing around this library, there is something which is named walkability index. If I'm interested in any location on Earth, I'm interested how the place is walkable. Okay, so can I walk to the school? Can I walk to school? Can I go to kindergarten? Can I walk to shop? So this is somehow the standard of living in the city, how easy it's to walk. And I'm working on attractiveness index, and it works like this, that it's building a spatial attractiveness index from the point of interest data. And this is the locations of mid-strata center, and it's building some aggregates on the base of the data. So this is querying an attractiveness index. So this is also the Python library. You can find this on my GitHub account also with this code in Jupyter Notebook if you want to experiment with that and if you want to extract such information. So here is an example of this index. So searching this index is very fast. It takes some roughly like 50 microseconds per query. So actually it's possible, for example, to take a granularity. So here's a granularity of 100 meters step by step and take the entire state or entire country and just point by point to calculate the walkability. So this is a restaurant walkability. So how many restaurants I have within some range. So there are some ways how to aggregate it. And you can see the intensity of color. So you can see, of course, all the restaurants here in Boston are in the downtown. So all those packages are available online. Also online, if you go into my GitHub account, which you can easily find by typing my name, you can find sample Jupyter notebooks. So thank you very much for this attention. Maybe I can even take one question if possible, then thank you. Anybody has a question?
Okay, thank you. The grid is showing like it's like it looks like a regular grid. So I'm seeing stuff over the Charles River. So I mean, like how does?
Yes.
Yeah.
That's a good question. So the question was about stuff over the river. So it's using Euclidean distance, and it should use the distance using the roads. So it's using here Euclidean, just a simple Euclidean distance. So that's why you see the color.
Yeah, we'll take any other questions offline. And yeah, thanks to speaker again.